Oh, look, my wife just said like I'll probably get back on Brussels.
Yeah. Tell them what you are saying.
I will land on Sunday. Tuesday.
Yeah, there's
Because
I think because of static flights.
Yeah? Okay, so Rachel. It's 40, yeah? Okay, so we're going to be starting with the second part of OPSEC. So please take your seats if you want and can. Okay, cool. Thanks. Stefan, please.
Good afternoon, and thank you for listening. I will be talking about a configuration file format for network services on leaf devices, which is a bit of a bulky term to describe end-user devices like a laptop or a smartphone, maybe smart watches, and maybe even IoT devices, all of which could benefit from being configured properly, and not all of them can easily be configured properly. So, first a little preface, because you might wonder, hey, why is this guy at OPSEC? I've seen him at other occasions before. So I was presenting something very similar in both Ops Area Working Group, IETF91, and in SAG in IETF93. Back then, with a slightly different name, I was only calling this EAP metadata, not netconfig metadata. But well, I'm here because this topic definitely has an operational component. You want to make sure that some kind of device actually works and people get network service. But there's also a security component, because you also want things to be configured so securely that nothing bad happens with the device once it's on the network. Some examples for random protocols here. So imagine you're configuring some IMAP access and you didn't select start TLS, but instead some default was about start TLS if available. So this means the man in the middle can just redact the start TLS capability out of your conversation, and you go on without TLS. Same thing on Wi-Fi networks, which is closer to my heart. You can verify the server certificate of your EAP server when you authenticate to a Wi-Fi network, or you can't. And the defaults in many operating systems are actually don't verify anything, and that gets you in an unpleasant position. So the draft I'm presenting here today is actually has grown out of these comments from Ops Area Working Group and from SAG, and it's now significantly extended according to these comments. So here on this slide here, this is the one big use case which motivated me for starting this work at all. So I'm a Wi-Fi person, and we have this wonderfully secure network called EduRoam, which is based on EAP and IEEE 802.1x. And this is really a perfectly secure protocol. Many decades of work in the IETF in this. This is using EAP. And the story goes that when you connect to the network, the first thing that happens is that the end user device authenticates which network it is talking to. So there's some kind of server certificate being presented by the authentication server, and the end user device verifies, yes, I can safely send my username and password to this very server because I know this is the right server to talk to. Only after this verification of the server side has been done, the client actually sends username, password, or whatever he has to authenticate. We use this extensible authentication protocol, EAP, and this is really one of those cases where you say, wonderful, nothing can possibly go wrong. EAP was carefully designed, and you can't do this incorrectly. This is a nice theory, but the problem with this is there is some practice in this, and we have learned that this is pretty much a hard fail, and this doesn't work as expected. The problem we have is that client devices have to be configured by end users in many cases. So there are some enterprise deployments where the admin actually does everything. It's still manual work, but at least we can hope it gets done correctly. But if you're talking bring your own device and actual end users fiddling with settings on the laptop which they don't understand, things typically go wrong. So what we see is that many user interfaces, like on Android, basically ask you, oh, you don't want to validate this server certificate, do you? And you actually have to manually say, oh, yes, I want this server certificate verification to actually get to security. And as it happens, nobody ever does that. So what we have learned is that the most carefully designed auth protocol can't deliver its promises if the users don't get all the settings right. And the main problem we see here is actually it's easy enough to get some kind of configuration which is enough to get you online, but insecurely so. If you just tap on an enterprise network, you don't verify the server certificate, you can just type in your username and your password. And if you're connected to the genuine network, that's all fine. And your username and password gets validated and you're online. But as it happens, a rogue access point could just present itself with the same SSID. And since you don't verify the server certificate, you just send the username and password to some random third party. That's not good. It's kind of a zombie state. It's good enough to work, but it's not good enough to be secure. And unfortunately, we see that quite a lot in the deployed world out there. So what you have here is a kind of an odd situation. You have something that was designed to work, but somehow it doesn't, and you wonder who's to blame for that, or just to wake you up with some random animation asking the question, who killed the pig? So on one side of the wall, here is a design team which created a wonderful protocol and something that grunts and squeaks and all nice stuff. And on the other side is the unsuspecting user who doesn't know anything what happened on the other side. So somebody designed a protocol, and the end user doesn't know under which conditions is it secure, what do I have to do to deploy this securely. And since he knows nothing, he particularly doesn't know that there is an incoming pig and that he's supposed to catch it and where exactly it's coming over the wall. So it could be standing at any point. And as a result, this wonderful design team with its complicated protocol here just throws the thing over the wall. The user is not in a position to actually receive the pig correctly, and it falls on the floor and is dead. And now the big question is, okay, who is responsible for that? And the user will say, okay, I didn't know that there was a pig coming, so I couldn't possibly catch it. And the design team says, oh, well, but when we had it on our side, it was actually working just as designed. It was grunting and squeaking like crazy when we threw it over the wall, so it must be your fault. On first iteration, you could just say, well, nobody's really at fault. The pig was victim of circumstance. But I'm arguing that in a second iteration, you should think, actually, the protocol designers are at fault, and that's the IETF in our case, because if you create something really, really complex, and you have to have all this complexity on the end user side, and then you don't actually make it easy to get all that complexity off of the end user, then, well, you've done a suboptimal job. So now the question is how many pigs die and how many actually get caught by end users. And well, the news is that's pretty bad. There are many studies happening, mostly in Germany, also other places, about how much badness is there out there in our eduroam network. And well, these people found out that a share of 52% wrongly configured devices existed, and out of which 20% just sent the username in clear text to a random attacker. So we are not talking about a bottom of the barrel situation here. It's not just those few users who didn't care enough to get things right. This is actually a slight majority of devices which just don't care enough and throw their credentials away. Unfortunately, I have to say this was even with administrators at the university where this was conducted, who were really loving and caring. So a few weeks before they actually ran the test, they informed users how important it is, and they gave them all the instructions, and they told users, okay, do it now. You're insecure if you don't do it. And even with that, 50% failed. And I think that's pretty much a catastrophe security-wise. So we really should be doing something about this. The same study also has some silver lining on the horizon, because they found out something else as well. The comparatively small share of 13% of wrongly configured Apple devices might be due to simplifications of the Wi-Fi configuration by importing pre-built configuration profiles. Hey, that's good news. So the difference between Apple and, not pointing any fingers, but let's say Android, is that Apple has this config format, a mobile config file, and there you can put all kinds of service configurations in, not just Wi-Fi, it's also about VPNs and whatnot. The fundamental difference is, as an administrator, you can give your user a simple message. Click on this file, hit OK, or whatever comes up, and then all is done. You don't have to know or care about any of these security properties. And well, it seems to work. So this is clearly the way to go. So this is why I started this, and it used to be just about the EAP configuration parts for enterprise Wi-Fi networking. After some comments here in the IETF, we changed the coverage to do more than just E-based Wi-Fi, but I could use some help here, and that's on the next slide. So what I have here is, first of all, the realization that some of the things you use for your Wi-Fi network can probably be reused. So if you have a root CA certificate for your server name verification, if it's good for Wi-Fi, maybe your VPN server uses the same root certificate. So maybe you want to specify this once in the configuration file and reference it from the Wi-Fi and from the VPN configuration. One thing we also think we're doing actually better than Apple is that the same username and password is often used for more than one service. So if you have some kind of single sign-on, chances are that the same username and password is valid for all your services. So you might have VPN, Wi-Fi, you have IMAP access. And if you do this on an Apple mobile config file, you have 4 Wi-Fi networks in the VPN and an IMAP server. During the import of the config file, you will be asked for 6 times, what is the username for this? What is the password for this? And there is no way in the proprietary Apple format to say, okay, ask the user once for his credentials and apply it to all those services. Needless to say, our draft now does that. So it assigns UUIDs to all the components in these config files and allows for cross-references between all those services. Another comment I got was, I started with XML because I like XML, but the ops people told me I should really be using Yang. So this new draft here is now a Yang module. Hopefully, people tell me this is quite extensible, so that if you want to plug more services into this config format, you can just do that. Well, I'm the Wi-Fi person, so if you look at the Yang module, which is referenced in the draft, you will see that Wi-Fi and EAP get the bulk of detail here, because I know that best. And here I could use some people actually working with me to plug in some more services, particularly VPN. So if you do take a look at the draft is hopefully in an easy narrative style. It doesn't explain every single detail of the Yang module. You will see that we've taken some care to be extensible here. There is one block which is provider info. So when you import the config file, you should be told who is sending you this file and what are the terms of use of the network and so on. How can you reach the help desk if something goes wrong? That's some kind of meta information here. Then there is a block where you can specify certificates. These can be CA certificates, intermediates, client certificates, and so on. Then you have a block called client-side credentials, which can be hosted to store usernames and passwords, or maybe a private key to a certificate. It can also be pretty much empty, and you can just say, okay, this is a client-side credential, it has a UUID, but I'm not telling you the actual username and password. So when you consume this kind of config file, you would realize, okay, I have to ask the user for his username and password, but since there is a UUID attached to this block, even if it's otherwise empty, I can still say whatever the user puts in here once can be the credential for all kinds of other services in this file. Then, since we're talking about network configurations, there is something for IP settings, like DHCP, SLAAC, whatever is used to configure the network. If you use a network service which authenticates with EAP, of course, there is the EAP identity provider list, which is about EAP methods and their config parameters. And then the one thing I did for an actual network service is the Wi-Fi network. Of course, I care much about EAP-based networks, but of course, you can also configure open networks. And right now, as I'm talking, the CAP port working group is also meeting. And if you have a captive portal, and if these guys figure out what they want to have as configurable things on end user devices, this can also be extended to cover CAP port results. What the draft is currently quite silent about is one important thing, but we haven't figured it out yet. So these config files will need some kind of signature and encryption at some point. So we have Yang as a source format, which doesn't go on the wire anyway, but it produces XML and JSON formats, among others. So once you have these files in your hand, you may want to sign it just to figure out, is this actually coming from my provider? Is this the data I expect? Or did someone exchange it for me, which I would like to discover? And we have several options there. You can use XML signatures, use SMIME signatures, just like Apple does, Or if you have the JSON format, the Jose working group has something for you probably. Same thing for these config files. If they do carry sensitive information, like if the config file already contains a username and password pair for some service, you wouldn't want to send this unencryptedly, so you could either say, okay, I rely on transport level security, but that's kind of the lame answer. So if you want to do more, you could encrypt the XML file, or you can use the encryption for JSON from Jose again. We don't really know which path to take just yet. Since we are having one Android app which actually consumes an earlier version of this file, we took a look and we realized, okay, if we want to go XML signature and encryption, nothing on Android supports this, so we are forced to go with JSON. And there are some kits which do the signature and encryption for JSON. So that's the part we currently care about most, but of course this needs some more review and thinking. Right, pretty much done. Next steps for this draft. Of course, I would love to see people actually chiming in and say, okay, we have some network services like VPN, and we would also appreciate if these settings can be pushed to end-user devices and work on the Yang module. And also at some point, I would love to see this picked up in the IETF. That's why I came here, so that would be nice.
Cool, thank you. So actually, who in the room has read this draft at this point in time? Okay, one person. You're amazing, Tim. So I think one of your core reasons for being here is trying to get like some feedback and and information about the draft itself, and so we can get some discussion triggered. Tim, do you have any?
Tim Chan, yeah, I have read it, but I'm a bit biased being involved with Ed Jerome in this way Stefan is. But I think this type of work would be a very useful thing to do somehow. We just need to figure out how and where the best way to do it is, I think.
Stig Valens. So I haven't read the draft, and I was involved with Ed Jerome many years ago. But anyway, at least it sounds like a useful concept. It is really hard for users to get this right. And you know, there's been similar things a little bit like tunnel setup protocols for IPv6 tunnels or STP files, for instance, or it's going to be useful to have some way of describing this in some kind of standard format and not have users supply all the parameters manually.
Okay, thanks guys. So I would just like to add one thing, since I have DHCP people here. So actually, even something simple like a DHCP configuration could benefit from this, because right now we have to care about rogue DHCP servers and what do we do about them, and there's complex considerations behind that. Actually, DHCP has an authenticated mode, which could just let you talk to one DHCP server, but you have to configure some kind of authentication key so that the client device knows which DHCP servers to talk to. This was never deployed anywhere, and I guess one of the reasons is it is just asked too much from an end user to manually configure DHCP to then get an automatic address. But if you have some kind of config format, you could just say, hey, here are the settings. Here is my DHCP server. This is the one to trust. And many problems could just go away.
On the side of automating the DHCP server, which is a good idea, there is also in the MIF working group some people that are working on provisioning domain that can be secure as well. So there could be a link there.
Tim Chan again. Stefan may come at me with a big stick if I say this, but I wonder whether this is something that might be relevant in the captive portal group as well, since presumably they want to do secure configuration of their devices. But it would be a bit ironic going there to solve an Ed Jerome problem.
Well, actually, I do go to cap ports, but I'm not standing here in parallel. But I'm not against captive portals. They have their use cases, and so I would love to incorporate them. Yeah.
Okay, so just a quick question actually here. So are there like any volunteers willing to to read the drafts further onwards and actually provide feedback on the email list? Okay, Fernando, anybody else? Joe? Okay. And Eric, Tim, and Stig. Okay, cool. Thank you.
Of course.
Alan DeCock has also read the draft. Sorry, Alan DeCock has also read the draft.
Okay, thank you.
My name is Anurai. I'm going to present on a draft Wink PIM MLD security, which is authored by 3 persons, Eric Wink, Antonius Adlazes, who works for as a researcher for an agency in the Netherlands, and myself. The background of this draft is that in the organization where I work, we do a lot of protocol and security research. And like 2 years ago, we started looking at MLD security from a very practical perspective, which means we build a test lab with different operating systems, hosts, and some devices from a specific vendor, and had a look at the interaction and the potential attack paths and vulnerabilities. And this is kind of the context or the background of this draft. The presentation is deliberately very, very simple. It's just 3 slides after this one. The first one is a high-level problem statement, then I'll cover vulnerabilities and associated attacks, and what we in the draft suggest as mitigating controls. The draft is right now in the status of an individual draft in the PIM working group, but given the operational implications of this one and aligned with the charter of OPSEC, it was suggested to present it here as well. The high-level problem statement kind of is that MLD has a specific, or maybe not so specific actually, relationship with ND, which presumably goes back to this statement in RFC 4861, which says joining the solicited node group, which, 4861 is about neighbor discovery, is done by means of MLD. And there is the statement is done, which can either be like descriptive, describing reality, or be prescriptive or normative, as RFC would say, how it should be done. Point is that, strictly speaking, when looking at MLD, I assume most people in the room are familiar with what MLD does. Very shortly, it's about forwarding. It's for routers to find out on an adjacent link, which is there actually listeners interested in certain multicast groups. For that purpose, routers send out packets, so-called queries, asking hosts on the link, like, are you interested in any multicast groups? And if so, which are those? And hosts can respond to these by means of report packets, signaling like, yes, I'm interested in getting certain multicast traffic. So the background it's supposed to exist in a world of interdomain multicast traffic. Otherwise, one could say it doesn't make too much sense to have MLD. But in 4861, there is a relationship of solicited node and MLD, which means when we looked at it, that pretty much all, or at least in our lab, all operating systems involved had MLD running, being active by default, enabled, except for OpenBSD, and sending MLD reports even without being queried as part of their interface initialization process. So it's there. As I stated, pretty much every operating system has it, but it's susceptible to certain attacks at the very same moment. And these attacks are somewhat based on the fact that MLD has certain properties as a protocol. I mean, there's 2 versions, MLD v1, specified as of 2710, and MLD v2 mainly specified in RFC 3810. I won't cover the specifics of the differences, but suffice to say that both specs work upon the assumption of a trusted local link, and the properties of the protocol are, amongst others, it's expected that hosts only process MLD packets which have a hop limit of 1. It is somewhat, stated in the RFC in 3810, for debugging purposes, it's expected that MLD mainly communicates by means of certain multicast addresses, which is all MLD capable hosts, FF0216 and FF0202, all or routers, but it is allowed that MLD communicates by means of unicast and both for global unicast and link local unicast addresses, which doesn't make too much sense, but it's still permitted, and we will see this is a source of certain problems. And the third one is there's an active carrier. There's only one on the local link, and this one is determined by, say, all MLD capable routers, and the one with the lowest link local IPv6 address wins. So there's an election process which can be easily forged. These are the properties, and there's three main types of attacks that we identified. First, it's very easy to enumerate hosts. Actually, you can do so passively. One doesn't have to interact actively, just listen to MLD, and one will see which hosts are active on a local link, and it is easy to identify the operating system as the hosts join multicast groups depending on their, like Windows joins LLMNR group, and Linux systems join MDNS once the Avahi daemon is running. So it's easy to identify active speakers and to identify their operating system, which in itself isn't a big deal, but it's one of the potential attack paths. The other two are much more interesting. I'll cover those in a second, but Stig, you might have a comment here or a question actually.
Yeah, maybe more a question as Stig van As. So trying to remember from the draft, but the issue with unicast, is that mainly for like off-link attacks, or are there other issues with unicast as well, or?
Let me postpone the response
Okay.
to the point when I cover the types of attacks. Actually, there is issues with this unicast communication. I'll get back to this in a second. The second, much more interesting, say, attack path is flooding and amplification attacks. First, it's easy to flood the local link by, say, send an MLD query, a forged one, and create a high number of answers. Usually, you can expect each host to respond for, if it's MLD v2, but with v1 it's a bit different. It doesn't get better in any case. For every multicast group that the host has joined, which is about 4 by default, send 2 reports, and this is done by every host. So simply math, assume there's 200 active hosts on a link. You send 1 packet, you get 2 by 4 by 200 packets back. So it's 1,600 packets by just sending 1. So there's a high amplification vector, which can be easily abused to flood the local link. And we did some testing. We flooded actual devices by sending specific packets just to them. And we were able, with one simple tool, sending packets to high-end, in that case, Cisco devices, we were able to render an ASR 1002, in that case, unresponsive, by just sending packets from one single host. And an ASR 1000, that is not like, that's not a Soho device. And there's the third type of devices, and now I get back to your question, Stig. The point is, once you're on the local link, it's pretty easy to exclude or to disrupt multicast streaming, both for MLD-v2 and v1. The specifics are a bit different. We have a technical report, a very detailed one, laying out the attack types. The basic rationale is first step, take over the carrier role, which is easy. Second step is send, and now comes the unicast thing, send unicast packets to the former carriers, which are still in forwarding state, like the active routers on the link. You send by unicast packets like telling, please, MLD done, or report, leave the group messages. What happens then is, usually I'll depict it for MLD-v1 as this is the easier case. The carrier will like, doesn't keep state who are the actual listeners. It just keeps state there is at least one. So once such a packet is received, like I'm leaving the group, the querier sends out a so-called last listener query, like, okay, have you been the last guy, or is there anybody else? And the remaining hosts are expected to reply on that. If you send, and we did all this in practice, so it actually works. If you send unicast to those hosts, no, you don't have to send unicast. You just send another report message, so they think, oh wait, we don't have to respond, and the forwarding, the pre-queries, earlier queries, which are still in forwarding state, now delete the group, as they send out the last listener query, didn't get a response, and they think, oh, there's nobody left. This works for V1 and V2 with a different, slightly different attack method, but actually what is possible, it's kind of easy to disrupt multicast streaming once you're on the local link. Before I cover the third part, which is the mitigating controls, which we describe in the draft and suggest.
Yeah, just one comment on that. Yeah, you know, one thing could be to say, okay, you should only send messages to to multicast group. But there's also, because of issues with multicast and layer 2 and like Wi-Fi, there are implementations that might use actually like a unicast MAC address as a destination, even for even though you send the MLD report to multicast group address, it might be actually unicasted anyway at layer 2. So even if the implementation checks that it was sent to the multicast group, it might be tricked and actually be the only one that got that message.
Okay, thanks. Yeah, this brings me directly to what do we suggest as laid out in the draft. There is two main things that we actually suggest. The first one is we don't think there is too much reason why hosts should be permitted to send out queries. They are supposed to send reports in response to queries sent out by routers. So similar to RA guard, we suggest coming up with a feature which we right now call MLD guard, which essentially says, which is a stateless, simple filtering ICMPv6 type 130 to inhibit hosts from sending queries. This would probably pretty much block most of the attacks that we described. It will still allow a host to send a high number of malformed responses, reports, which we did. That is one thing, but it will block many of the attacks. The second path that we actually suggest is kind of work on these properties of MLD, which actually enable those attacks, which is the handling of the hop limit, which could be substituted by like send packets with 255 and check upon reception if they still have 255. There is this thing, well, should it be allowed to get MLD packets on unicast addresses? So overall, we bring up the idea of working on some of the protocol properties, but this would mean, working on a new spec or on a piece of the 2710 and 3810. This might be much more difficult. Overall, the MLD guard feature, that would be, we think, a very helpful addition for like protecting from this MLD-based stuff. Thank you for listening so far.
A couple of comments, if I may, Stig van As. So I certainly understand there are security issues with unicast, and it's interesting what you explained earlier. I have some concerns about making it illegal, though. For instance, there's been talk about various optimizations or improvements, so MLD where unicast might be helpful. And for one example is if you do explicit tracking, so you know exactly who has joined the multicast group. When you send like the last, if to check if there's still receivers, if people are still interested, there's suggestions that you could unicast queries to just those particular members instead of multicasting to everyone on the link. And there's some other suggestions too for basically how to better handle Wi-Fi and multicast. But at least that's something we should discuss. For the hop limit, I wish it said 255 in the spec, and we could change it, but I'm a little bit concerned about how we would actually do that, because it would take a long time to get host stacks upgraded, and you can't really mandate this on the router side until you know that all your hosts support this. It does say, though, in the spec, for at least MLDV2, that you should use a link local source address. And in theory, routers should not forward those packets. It would be interesting to see if there are implementations that actually do it anyway. But if the routers don't forward link local source address packets, and the router implementations and host implementations check for a source being link local, then in theory, we wouldn't need that 255 hop limit. But no, the 255 hop limit would have been a very easy and good way of, making this more secure.
Yeah, I have a comment on this, like the idea of keeping state of actual listeners to address those on a like unicast basis once a leave or a done message has been received. Personally, I would be quite skeptical about this, as it would heavily increase the amount of state to be kept on an MLD carrier. And in general, I'm not a big fan of, given my security background, of keeping much state on routers. So intuitively, I would be skeptical about that one. As I stated, I think the most important thing would be having like an MLD guard feature, as this is easy to implement. So an equivalent to 6105 just for MLD, that could be a very helpful thing, we assume.
I also wonder if you, if you do something like MLD guard, are there ways you could also try to validate that you get reports from the right, sent from the right host? I don't know. Can someone detect that hosts are trying to send invalid reports? Yeah, I know.
Tim Chan, yeah. So I think the RA guard type approach has a feel. I'm not quite sure how you would do that to be 100% sure. In the question of the unicast, are you thinking of this being an attack within subnet that the hosts are on, or remote, or what?
It's actually all the attacks that we...
I can't hear you. Can you put the microphone closer to your mouth?
In the subnet. So they were on the adjacent link. So
Still can't hear you. So.
We didn't, given actually the... Doesn't it work?
Put it closer to your mouth.
It was intra-subnet.
No, closer, not further.
Okay. Yeah, that is easy, kind of. So the question was if the attacks that we performed were on link or remote. Actually, they were on link, so on the adjacent link. So we and we checked the number of operating systems, none of which accepted packets with a non-link local source address. Some accepted packets with a hop limit bigger than 1, which they shouldn't, but still they did. But I don't think remote attacks, from what we've seen, would be very feasible. But part of the attacks that I laid out is that you can interact in a one-to-one manner without the other host noticing. That is there is a problem with the unicast addresses.
Yeah, Tim Chan again. So I assume if it's remote, it's going to be very difficult for the remote host to determine what the unicast address to send that message to would be. On link, I guess you can apply these types of filtering methods so that other hosts on the same subnet may not even see the reports that the host is sending, I guess.
Yeah, that's the exact point.
So again, they wouldn't know who's participating in the multicast. So. I think I agree with Stig. I don't think the unicast thing is that important if you do the MLD guard approach.
Yeah.
Okay, Stig with us again. So I certainly see dangers of attacks with unicast off-link. I mean, you can send packets so they happen to have hop limit 1 by the time they reach the link, right? And you can often guess, I would say, an address of, say, like the carrier. Like lots of people, they would give like the router, like, you know, the V6 global address of a router is often like 64 prefix column 1, for instance. So you could send a unicast packet to that address and specify maybe a link local address in the packet that is like very low, like all 0, well, more or less 0, so that the query might think, oh, there is another query here, for instance. I don't know, but with multicast, it's really hard to do an off-link attack, right? At least I think most implementations check that the group is the correct multicast group. And if you are off-link and you have to do multicast, I mean, if it's not a link local multicast group, then someone on the link must have joined the group for it to be forwarded to the link. So it's very hard to do an off-link attack with multicast.
Yeah, I would agree with that.
Okay, in the interest of time, and we need to close the discussion right now, and let's continue this discussion over the mailing list would be way better.
Yeah, just, you know, just a clarification. On which email list do you prefer to have this, you know, if there's like any feedback? PIM? PIM, okay. Yeah. Yeah. Yeah, I just wanted to make, you know, to clarify. Thanks. The PIM list. Of course.
So this is Fernando presenting the document on defeating attacks which employ spoof ICMP and ICMP version 6 error messages. It is an update of the document that we had presented at the last OPSEC meeting based on the feedback that we got at that point. So the goal of this document is to specify filtering that could be enforced close to the end user, such that attacks that rely on spoof error messages can be mitigated. As I said, the goal is to, you know, deploy this filtering policy next to the user, and must never be applied in cases where you have multi-home scenarios. Okay. This is a kind of a background or overview on the ICMP error message generation. So in this case, we have the host A that is trying to send something to host D, and if the router finds that there is some sort of error, it will send an ICMP error with the structure that we have here. Okay. Obviously, the source address of the ICMP error will be that of the router. The destination address obviously will be that of the node that was sending the original packet, and then inside the payload of the ICMP error message, you will see the router will include a chunk of the packet that triggered the error message. So it was a packet sent from A to D. Okay. So one thing that is important is that obviously, since these error messages could be sent from any potential router in the network, if you want to perform an ICMP-based attack, you don't really need to spoof the source address of the error messages, because, you know, the node that is receiving the error message doesn't really know from which router that error is coming. So this is a scenario in which we have this node here trying to attack a connection between these two nodes up here, right? So the goal is to enforce a filtering policy in this router that is next to the user, so that this router can prevent this client from performing ICMP-based error messages-based attacks against, you know, third-party connections, such as, for example, this one. If this node here tried to do that, we could say that this node could easily use, for example, its sound source address I mean, it doesn't need to spoof its source address at all. It can pretend to be a router that was, in the path of these packets. The destination address of the error message would be obviously the target of the attack. In this case, would be this node. Okay. So obviously, this error message has to pretend that it was elicited by a packet sent from this node to this other node. So that's why the source address here is the address of this node, and the destination address is the IP address of this other node. Now, if you look here, okay, this node can tell that, based on the destination address, this packet couldn't possibly be generated. So the idea here is that we don't look at the source or destination addresses of the outer packets because they don't need to be spoofed at all, but actually look at the address that is here in this error message, okay? Obviously, this network couldn't possibly have received this packet because it's meant for a completely different network, okay? Again, we are assuming that there is no multi-homing here, and it was clear, in the first slide. You don't deploy this in scenarios in which you have multi-homing. So what is the rule like? Well, if the destination address that is embedded in the ICMP error message belongs to your own network, you let the packet go through. If it doesn't, you just drop the packet. It's that simple. And what the kind of attacks that this filtering can prevent is essentially any attacks that are based on spoof ICMP error messages. There have been attacks like, the traditional nuke attacks where you spoof an ICMP error and that triggers the abortion or termination of a TCP connection. But other possible attacks are, for example, those in which you spoof fragmentation needed by the FBit set or an ICMP packet to big message that, depending on, whether that's P6 or V4, can, lead to a reduction in the MTU that is being used for the connection, or even, in the case of IPv6, those error messages could be employed to trigger fragmentation. I don't know if there are any comments. So we should require, our intent is to get this document as a working group item. I guess that, well, first of all, we need feedback.
We do need feedback as well in interaction, pretty much like my draft, so I share your concern. We need interaction there and momentum.
Any folks meaning to take a look if they haven't?
Okay.
Thanks. So the next one, right?
Yeah.
So this other document is about the role of firewalls in network security. As a kind of background on this particular document, this version of the document is based on a document that had been published or aimed at the Ops Area Working Group a few years ago. It had actually been adopted at the time. I had liked that document, and after a while, I contacted the authors regarding what was the status of that document. And it resulted that, it was the case that this document had been dropped. Apparently, as far as I know, because there were two authors and they didn't share the same view on the contents. So I asked them if they would be willing to, just to revive the document, and they said they wouldn't, but if I wanted to do it, I could. So I did. We presented this document, I don't recall if once or a couple of times in the Ops Area Working Group. The reason for which we did it there was because that's where the document had always been discussed. And for this meeting, actually, I think we were planning to do it in OPS area again, and we were suggested to present it in OPSEC. So that's what we are doing here. What are the goals of this document? And this is actually, one of the things that we changed from previous versions. Even if it's if it's the first time that you get to hear about this document, last time that we presented this, some folks asked, well, what specifically are you trying to achieve with this document? So first item is to recognize the role of firewalls in internet architecture, and this is essentially saying that quite a few times firewalls are flagged as something that is evil. So this document is trying to do actually the contrary, saying that they are, part of the architecture. It also tries to analyze common kinds of firewalls and claims associated with them, assumptions made around firewalls, analyze trade-offs in different paradigms. We try to provide some conceptual guidance when it comes to the use and deployment of firewalls. Identify harmful behavior that is at times, implemented in firewalls, such as stuff that they do that prevents deployment of protocols and so on, and possibly trigger other work in this area. So I will try to briefly, go through the stuff that is covered in this document. First of all, a definition of what we mean by firewall. Last time that we presented this, folks were asking, well, what are you talking about? And an application layer firewall, layer 2 firewall, and so on. And what we ended up doing is saying that it doesn't really matter. So what we are trying to describe here is some device or software that enforces some sort of policy on the traffic that goes through that device. And obviously, depending on the layer at which this device or software operates, well, obviously there are the possible, let's say, policies that it can enforce are different. So things like, whether the device or software resides in a host or in the network, whether it's implemented, in special purpose hardware and so on, the specific layer at which the device operates. We think that it's like, it's a detail, an implementation detail. Obviously, again, that, results in implications regarding what kind of policies you can, enforce. But what we are meaning with this is that we are not focusing on any kind of, specific layer firewall, but, on firewalls as a general concept. The role of firewalls in network security, essentially what we say is that they provide prophylactic perimeter security, and essentially means that it's not a replacement for more powerful security measures, but it's like a first line of defense. And the analogy that is in this document, which was actually in Fred Baker's first version, is that the function of a firewall is like analogous to the human skin, which means that it prevents you from getting infected with things, but that doesn't mean that it's the, let's say, only protection that your body has. Another topic that this document covers is the relationship between the firewalls and the end-to-end principle. And one of the usual comments that you hear when talking about firewalls is that essentially they are evil because they break the end-to-end principle. And what this document argues is that that's not really the case. And essentially the end-to-end principle argues in favor of simplicity, inconsistent behavior. But it doesn't really mean that, for example, it doesn't really argue against things such as firewalling, like enforcing consistent, for example, policies for example, security reasons. Common kinds of firewalls. We briefly describe 3 different types, like context or zone-based firewalls, pervasive routing-based measures, and IPS systems. We categorize firewalls into these 3 different kinds and provide a brief discussion of those. We briefly, cover the 2 main firewall strategies: default deny and default allow, and the implications of that. We also discuss assumptions in general that are usually made in firewalls, and some of these assumptions change. For example, when you move from V4 to V6. For example, in the case of IPv4, generally the IP addresses and the ports are assumed to be stable. In the case of IPv6, this is not really the case. When you have temporary addresses, the assumption of IP addresses being stable is not longer the case. And we also discussed or mentioned the fact that, in general, many firewalls assume that the service port identifies the protocol that is actually, employing that port number. And essentially, we say that that is not actually the case. Obviously, that's not news. But what we say here is that, for example, the assumption that a given port number identifies the service is not really the case. And probably, if you really mean to block a specific, let's say, protocol or service, well, you have to make sure that you identify, that protocol or service, not just based on the port number, but actually based on the protocol itself. Okay. We also have some comments on stateless versus stateful filtering, essentially discuss the trade-off. And for example, note that in the case of stateful filtering, there are cases in which people might deploy a stateful device to mitigate, or to improve security. Whereas in the case of denial of service attacks, that's actually not generally a good idea, because the device, in this case the firewall, can be the target of the denial of service itself. We also have some text on areas where firewalls could do better. This is not meant to be complete, but we mentioned, for example, the case where firewalls tries to enforce protocol syntax, and there are obviously many examples of this. For example, where a firewall, let's say, if you have TCP, at the time there were firewalls that were checking whether the ECN bits were set to 0, and obviously when we tried to deploy ACN, that changed, and at the time, obviously there was a problem for ECN deployment, and it's not just for ECN. DNS SEC and other protocols suffer from the same thing. So here we discussed the topic, but at the general level, but we might, end up, either including more specific discussion in this document, or possibly doing separate document or separate documents with specific issues that are affecting concrete protocols. So I don't know if there are any comments. So the last time that we left this in the Ops area working group, let's say the remaining item, or what we were required at the time, was to try to clearly specify the goals of the document, and we took that advice, applied that to this version, and this is what we came up with. So I don't know if there are any comments, if people have read this, if they think it's worth working group adoption.
Who wrote this document?
Bill Yeagley. I mean, over time, it's generated a fair amount of controversy, just not in this group, because weirdly enough, I think most people here understand what firewalls are for. So I think it's actually a bit of a challenge to get it over the hump, as it were, to say adoption or working group last call. But that's just my opinion.
Yeah, I think actually even before, going to, asking for adoption, I think I would prefer to see some discussion on the email list itself. So I would really encourage people, to sort of like read the document and provide feedback. So we have an understanding of, how this document can make, networks, more secure and improve, the, security within networks.
And the operational aspects. Yeah. So, okay, please. Next time, last.
So this final document is about requirements for IPv6 enterprise firewalls. We had authored a first version of this document a while ago. I don't know if it was like a couple of years ago. For some reason, we just forgot about the document, and a number of people, yeah, probably. And a number of people actually asked us, well, what about that document? Are you going to revise it, or what are you going to do with it? So essentially what we did, we revised it. To be honest, I don't really know whether in this last rev we actually applied any changes, or we just, bring it up, to for it not to be expired, and so that, we could discuss it. So for the most part, this presentation is, just to describe what we are currently doing. It's an extremely drafty version of the document, okay? And the goal is to get input from you so that, you can tell us whether you think we are on the right track, whether there's stuff that you should be taken out of the document, whether it makes sense to pursue this or not, etc. So what is this document about? It actually probably tries to do a lot in the same document, which is, part of the feedback that we want to hear from you about. So it's kind of like difficult to know what to expect when you talk about, an IPv6 firewall, for many different reasons, including, less confidence with the protocols and less operational experience. So it's not unusual the case that, when someone wants to get a V6 firewall, they have to resort to producing their own RFP from scratch. Actually, this document is exactly based on that, on an RFP that was produced by guys that were trying to buy V6 firewalls, but didn't have anything actually to to show vendors regarding what they wanted in terms of firewalls. This document tries to fill that gap so that folks don't have to write their own stuff every time they want to specify what they mean by a V6 firewall. And as I said, this document is actually based on an actual RFP. So this document has a large number of requirements when it comes to firewalls. General security features, IPv6 specific features, VPN security requirements, etc., etc., etc. So you can see that it covers a very, very broad, number of categories. For each of those areas where this document has a set of requirements, it tries to specify whether that that requirement is mandatory, recommended, or optional. Whether that has to be there, whether that is desired but not required, or whether that's optional and it's up to whatever whoever is producing that firewall. The goal is obviously to have something like to refer to when it comes to what we mean by a V6 firewall. So feedback that we have received so far. So essentially what we did, as I mentioned, was to essentially grab that original RFP that had been produced by Marco. We changed some stuff, removed some stuff, and we came up with this document based on that. And the feedback that we got so far is that, for example, that we should separate between stateful and stateless firewalls. Not sure if folks were meaning to do that within the same document, or whether they were meaning that they should actually be separate documents. All the feedback that we received is that when it comes to anything that is low-level details on what to do with TCP, UDP, and IPv6 should be in separate documents. So this, you could think of this for the most part as something that is talking about products, Whereas in the case of the TCP, UDP, and IPv6 low-level stuff, there could be a document that describes how to implement those things, or clearly specify what we are referring with those requirements, without getting into such a broad discussion of features such as the ones that are described in this document. Other feedback was about more consistent use of defined terminology. And what else? And then I think the last item on which we received feedback is that it was okay to actually say what kind of data should be offered to the user, but we shouldn't even try to specify how anything regarding how that data should be shown or should be available to users. So comments.
Hi, Tim Jones. So I had a quick glance through it there. I haven't read it in detail. It seems to have some useful information in it. I note you don't make any reference to RIPE 554. That's a document that does discuss requirements, enumerate list requirements for network security devices amongst all sorts of other enterprise IPv6 devices, switches, routers, blah, blah, blah. And it does that for sort of standard firewall, for an IPS, and for an application firewall, 3 different categories. So you might want to look at that. I think RIPE 554 in itself is not something you can take and cut and paste a tender from, obviously. I don't think this is. So I think the most useful thing for this is for people that want to know that the firewall that they're getting has got the v6 functionality they need, not necessarily how to configure it, but to make sure it's got the functionality. Mm-hmm. So I think that should be the focus of it. RIPE 554 does, in the network device section, include in that section the v6 requirements as well for the firewall device. So on that analogy, you should keep that in your document. But shaping it to be something that can really help with a specification for a tender, I think, is the most useful thing.
And more generally, I would love to get the feeling of the working group regarding whether a document with requirements belongs to OPSEC or even the IETF, rather compared to RIPE. Any comments on this? Sure. Well, I mean, your document about requirement belongs to OPSEC security for sure, operation. I got my reservation somehow there, but what is the feeling of the
So I think if, say, Jan Zors was here, he'd be saying it should be a BCOP, or he might say take it to the RIPE community and improve 554, since 554 is in itself an update to a previous version. I don't know whether the other regional registry communities have done similar things, but I think RIPE 554 is referred to in an awful lot of places as good practice for enterprise v6 equipment and the functionality you need.
Other comments on this specific topic? Then, if you don't mind. Just to be clear that I'm a plain attendees now. Regarding the section of everything, thank you so much. Regarding the requirement section, there is one I would really, really love to be removed. That's the one about denial of service. I do not want at all that an IETF document claims that a firewall can protect against the denial of service. I would really love you to remove this section completely. And I understand what you wanted is more blocking ping of death or this kind of stuff, but don't call it DOS. Rename the section.
Okay.
And then there is the generic section as well regarding the requirement actually apply to any firewall and not only to IPv6. So I would also remove it, to be honest. The generic section is basically is valid for any firewall, IPv4, IPv6.
So you say that rather than making this like v6 specific, just talk about firewalls and that's it.
Either this or remove those sections because they're not specific to v6.
Okay.
So be consistent, right, in the title and the requirements there. And then I think the VPN and the SOC sections with a lot of mast And it looks for me like a list of features into a commercial datasheet, like a list of features from a commercial firewall. So it should not be must. When you say it must present this, it's, I would say first nice to have, but it looks pretty much like non-technical requirement.
Well,
That very subjective requirement.
I would say that, and that's part of the feedback that we were after, is that what we have in the current version of this document is like a mix of many things. Because on one hand, you have stuff that is like low-level technical detail, and as you say, there's other stuff that is just talking mostly about products rather than like low-level details. So that's something on which we were actually asking for feedback.
Okay.
So I don't know what would be the, I guess, revised based on this on what.
Yeah, I think again, the main thing is to actually, have like, an email discussion on the list also,
Yep.
because that will probably draft, improvements in your document also.
Makes
So-
sense. Yeah.
So again, people, please, read the stuff and provide feedback and input.
Perfect. Thank you.
So it was the last document of the day. Anybody has any suggestions, comment, idea regarding OPSEC working group? Tim?
Tim Shane, I guess I'll bite. So there was a discussion in V6 Ops about what the IETF should and should not do in terms of specifying filtering. And I just wonder what you as chairs sat there think about what we should and shouldn't do. And if you're at V6 Ops, what you think about what the chairs or what was said there.
I mean, it's typically operational issue filtering, okay? As you know, my point of view on this document, if the IETF wants to specify the list of extension headers that in 2016 with the specific option, this specific subtype must be blocked, I'm all for it. The only issue is that most probably we will be adding more and more options in extension headers. So this list, as soon as public, is most probably deprecated. I mean, after a few years. So I'm unsure whether there is a big value there, but I don't mind. And it's a personal issue.
Yeah, I think one of the things we can do, and maybe it was a result, what came out of V6 Ops is people tend to be cautious and default block stuff, and just natural behavior, I suppose. And in my context, talking to universities running campus networks, that's what they tend to do. So I think we could maybe spin that to be more positive about these are the things you should definitely, well, we strongly recommend you allow through and the reasons for it, and be perhaps more positive about it. And the implied thing is, well, you can do what you like with the rest. Maybe that's a better approach rather than be prescriptive about what to block. Be aware, raise awareness of what you should allow through. So it's a bit like, is it 4860 or 4890 that talks about ICMP filtering and why you should not do block bulking of all ICMP messages, that type of thing. Maybe that's a better approach, but it would be nice to figure out how best to get these things progressed, because otherwise they sit there and get stalled discussing, or if you like, the politics of what we should and shouldn't be doing.
Yeah, Joel Yegley. I think, add a little to that, because I think there's something that I want to amplify, which is that there's a bit of a dramatic tension between what operators find necessary and what people say we should or should not do. And I personally like the idea that the community would be able to document what people do without necessarily saying that you should do those things, right? Because that actually, I think, informs protocol designers and protocol evolution a little bit, without actually making the things that I do that I find necessary normative for other people. right? And so I think that's where some of the useful discussion around what is observed behavior, without necessarily making value judgments, is actually pretty useful. But I think we can also be stronger than that, because we can actually, I think, characterize why people do the things that are observed, which actually does have a value judgment, but it's and it should inform other processes.
Tim Shanahan. So I think I agree with that completely. I think the interesting thing in the case of the extension header stuff in V6 is there's measurements you can take of the effect of what's happening, but it's a little bit harder when you try to tease out what the causes are. So Fernando has been informally speaking to some operators and produces a draft based on that, but that isn't representative of what everyone does, of course. So it's going to naturally be that's controversial or create discussion. So I think it's just about getting the right mindset, and when we're writing the documents, to think what's the most productive way of, most productive perspective to produce the document from. So I think what Joel just said is, you know, something we should bear in mind. I don't know whether Fernando agrees with that, but it would be nice to progress the type of things we're doing or trying to do in V6 Ops and get it through and do it the right way and have the most positive impact by doing it.
Fernando, I agree with that view. I would say that in any case, in V6 Ops, even when trying to do stuff with that mindset, we have a hard time. Just to name a specific item, we were presenting and discussing a document on the filtering of packets with extension headers, noting that we were just describing, something that operators were doing without actually saying that we were, recommending that to happen, and that was still controversial. So I'd probably say that it's probably easier or less controversial to just, describe what is being done, but at times that's not even enough. At times, apparently, the take is that we don't like that, even if that's happening.
Yeah, just to make an observation on that, Julie, again, extension headers in the real world, that document actually was kind of an interesting phenomenon, because it actually takes a value neutral position with respect to the observed behavior. So it passed relatively smoothly through the community, even making those observations. But the IESG doesn't like it that much, or didn't like it that much, because it doesn't take a position. So I mean, like there's a bit of a conflict there, albeit 3 abstentions are just abstentions and not discusses. So I take all the wins that I can get, and I think respect the idea that any consensus that we do produce around this is going to be pretty rough. And that's part of the reason that I encourage the observable results or the phenomenon or the recommendations that we produce to not look like they're strongly normative statements, because as with other firewall drafts and deployments, not everyone has the same vantage point.
So it looks like the AD got the final last word of the working group. So let's adjourn and enjoy your evening, and see you tomorrow. And thanks for coming. Somebody's coming for the
No, we have to bring them away somewhere. Yeah, it is. Actually, the mic's always on, so whatever you say, sometimes it's always recorded. So if you say something confidential, yeah. I've heard. Oh, really? If you listen to someone to the recording, you hear something weird stuff. Not that, but I mean, like even during the sessions, because their mics are open before it starts and after it starts, and people are negotiating sometimes on strategies how to handle a particular draft they either like or dislike.